Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to our fellow friends and our lecturer, Dr. Adam. My name is Muhammad Rushaidi bin Muhammad Azri, and I'm the leader from the group 10. First of all, I will introduce my group members. There is Zafira Rosetti, Nur Khalisa, Nur Nafisa, Muhammad Ridwan, and Nur Izzati. Our group have been chosen to make a question for topic that critically false damp oscillation. Okay, I will introduce the topic with my fellow group members. Okay, for first introduction, it is about simple harmonic motion. Okay, simple harmonic motion is very useful in many aspects, especially in engineering. However, it may seem like a physics topic that we have to study, but actually, if we care carefully to our surroundings, simple harmonic motion actually takes place everywhere around us, from the simple pendulum of a clock to a swaying bridge. However, what is exactly is simple harmonic motion and how it applies to our daily life, and why is this such an important concept? Okay, simple harmonic motion occurs when a particle or object moves back and forth within a stable equilibrium position under the influence of restoring force proportional to its displacement. And in most cases, this leads to the phenomena known as damping. Okay, for the damping, we'll continue with my fellow members.
Alright, damping is a process whereby energy is taken from the oscillating system, where frequency and amplitude will be reduced during the damping. When there is damping, amplitude will be decreased, but period will still be increasing. There are three types of damping, which is light damping, critically damping, and heavy damping. For our project, we'll be discussing about critically damping oscillation. Critically damping is when the system returns to its equilibrium position in the shortest possible time, without any oscillations. In other words, critically damped is the fastest way to return to equilibrium.
Okay, that's all for introduction. I will continue to the next part.
Assalamualaikum and very good morning. Today I will present about application of simple harmonic motion and damping. So me and my group have found that the application of simple harmonic damping is spring and damping. So elastic potential energy relates primarily to a spring, but springs are a major part of everyday life. They can be found in everything, from the shock absorber assembly of a motor vehicle to support a trampoline fabric, and in both cases, spring blunt the force of impact. If one will jump into a piece of trampoline fabric stretched across an ordinary table, one with no spring, the experience would not be much fun, because there would be a little bunch. On the other hand, the elastic potential energy of the trampoline spring ensures that anyone of normal weight who jump on the trampoline is liable to bounce some distance into the air. As a person's body comes down into the trampoline fabric, this stretches the fabric and hence the spring pull from a position of equilibrium. The spring acquires elastic potential energy, and this energy makes possible the upward bounce. Okay, next, as a car goes over a bump, the spring in its shock absorber assembly is compressed, but the elastic potential energy of the spring immediately forced back into a position of equilibrium, thus ensuring that the bump is not felt throughout the entire vehicle. However, spring vehicle also has a shock absorber. The shock absorber, a cylinder in which a piston pushes down a quantity of oil, acts as a damper. So that's it, an inhibitor of the spring oscillation. Thank you.
Okay, next, I will explain to you about the problem statement for our topic. The question start with 64 Newton weight scratches a spring of 0.5 meter in equilibrium. there is also damping component at c meter per second. Write an equation for which motion is critically damped and find the solution if y equal to 1 and y prime equal to 20 when r equal to 0.
Okay guys, now we will presenting about filler table.
Okay, the first fact for this problem is the weight of the load is 64 Newton, and the idea of this fact is the weight is hanging in perpendicular. The main issue is what is suitable position to hang the load. The second fact is spring stretch in 0.5 meter, and the idea of the fact is the spring is made of aluminium. And the learning issue is what is the stiffness of the spring. The third fact is in equilibrium condition. And the idea is the spring condition when no external force is applied. And the learning issue is how a spring can be an equilibrium condition.
Okay, next is the fact for number 5. Damping component at C in meter per second is unknown. So the idea is the external force is applied manually with constant energy with a hand. So the learning issue for this point is how is the force applied constantly. So next, point 6, motion is critically damped. So the ideas for this fact is the test is run in a high dense liquid. So for the learning issues, is the surrounding will affect the test? Okay, next facts is just we will put it in the
The video.
no
In the board.
bukan in the formula. Okay, the idea is no idea and no learning issue. So as for the action, we will find reference from internet, books, journal, and also mathematics module. Thank you.
Alright, the information that given in the equation is the weight of the load, which is 64 Newton, and the changes of the spring length, which is 0.5 meter. The changes of the spring length can be right like this or x. Okay, according to Hooke's law, F is equal to K is coefficient of the spring and x is displacement or the spring changes. At the same time, F also equal to mass times gravity. To find K, substitute x equal to 0.5 meter equal to 64 Newton, and then we got K equal to 128. And to find M, mg is equal to 64, and mass 64 is divided by the gravity, which is 9.81, and mass we got 6.5. Substitute all the information given into damped equations, and to find the roots of the equation, we need to replace the equation by 6.5 r squared plus cr plus 128 equal to 0. And to find the roots, replace with the equation negative b plus minus b squared minus 4c square root equal to 2a, which is a is equal to 6.5, b equal to c, and c equal to 128. This is the equation of the two roots will give a repeated root, which is represent critical force damped. So since it is critical, c squared minus 4mk or 4ab is equal to 0. So substitute substitute the value of k, we got c is equal to 57.69, near to 58. So to find the actual root for 1 and 2, since it is the repeated root, negative c is divided by 2m. Negative 58 divided by 2 times 6.5. We got negative 4.46 near to negative 5. Next step is, since it is given 2 repeated root, so the critical equation is y equal to c1 exponent RT plus C2 T exponent RT. And substitute the R equal to -5 since the root is -5, and Y prime is differentiate the Y. At the question also given the information Y equal to 1 since the root equal to 0 and the prime Y equal to 20, the root also 0. So substitute the value. We got substitute R equal to 0 and substitute Y equal to 1. So we got C1 is equal to 1 and substitute Y prime equal to 20, substitute R equal to 0, and we got C is equal to 25. And then the final equation, we need to rewrite this equation by substitute the C and C1. So we got C1 equal to 1 and C2 equal to 25, and this is the critical equation that the question need us to find out. Thank you.